In this video, we're going to find the total number of subsets of a set. So we're told that some set S that contains some certain number of objects in has 2 to the n subsets, and those subsets contain the empty set and the entire set S itself. Okay, so that seems like a handy piece of information if we ever need it, and it kind of seems like where in the world did 2 to the n come from? So let's just let that sit in the back of our noggin for now. And let's do this example. A small pizza restaurant offers 6 pizza toppings. You can get as many toppings as you would like, and you can get any combination of toppings. How many different pizzas are possible? So let's say, some people come in and they get no toppings. Some people come in, they get all 6. Some people get just pepperoni and just sausage. Some people get pepperoni and red peppers. We want to know how many different total pizzas are possible. Pizzas with no toppings, 1 topping, 2, yada, 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 to all 6. So in order to do that, we're going to calculate each of these possible scenarios individually. How many pizzas have no toppings? Okay, so how are we going to approach this? Well, you may be thinking there's only one, obviously. There's one pizza that has no toppings. And you are correct, there is. But to keep a pattern consistent with how we approach this problem, I'm going to write it this way. We have 6 options to choose from, and we want to choose none of them. We want no toppings. So we have 6 toppings, we want to choose none. Plug that into your calculator, and that comes out to be 1. There's one possible pizza with no toppings. Let's continue on. We have 6 toppings. We want to see how many pizzas are there that have 1 topping on there. So we could have a pizza that has only topping number 1, only topping number 2, and so on. Plug that in your calculator and you'll get 6. Okay, how many pizzas are there from our 6 toppings if we choose just 2? Remember, order doesn't matter. A pizza with pepperoni and sausage is the same as a pizza with sausage and pepperoni, so order doesn't matter. So what is 6 choose 2? Plug that in your calculator and you'll get 15. How many pizzas with 3 toppings, 4 toppings, 5 toppings, 6 toppings? If you would pause the video and finish completing the rest of these bullets, and then we will play the video and come back and we will figure out the answer to this problem. So I got that there were 20 pizzas possible that have 3 toppings on them. There were 15 pizzas that have 4 toppings. There were 6 pizzas that have 5 toppings, and there's just 1 pizza that has all of them, so that makes sense. You may see this pattern, right? No toppings and all toppings is 1. 1 topping and 5 toppings both have 6. 2 toppings and 4 toppings both have 15. And then 3 toppings has 20. So do you see that pattern there? Just as a fun tidbit of information, I will tell you that pattern exists because 6 choose 2 is equal to 6 choose 4. So as long as these 2 add up to that first number 6, those are like calculating the same number. Just the same, we see that 6 choose 1 would be the same as, what is 6 minus 1? 5. 6 choose 5. Those are the same. Just fun fact for the day. Okay, now that we know how many pizzas are possible with each of the individual number of toppings, we want to know how many, our original question, right, was how many different pizzas are possible. So no toppings plus 1 topping plus 2 toppings, 3 toppings. These would be all possible pizzas with all possible toppings. And that's what we just calculated. So let's add those up. So we get 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. So go ahead and add that up and you should get 64. Great. Now that was a heck of a lot of work. Why did we just do that? Well, we just did that because if you remember at the beginning of this video, I told you that there was this fact that we can find the total possible number of subsets, all of them, for some set that contains some amount of objects. In this case, our number of objects is 6. So then 2 to the 6 would be our total number of subsets, including the empty set. That's no toppings. And including the entire set, that's all the toppings. What is 2 to the power of 6? That's 64. That's where 64 comes from. It comes from adding up and doing all of this work with the combinations individually and finding each individual one out and then saying, oh yeah, all that's 64. But just a little shortcut to have is that we can just do 2 to the n in the future. I just wanted you to know where it came from.